Hello class, and welcome to today's algebra lesson, which is about systems of linear inequalities. By the end of today's lesson, you will be able to graph to find the solutions to systems of inequalities. So a system of inequalities is taking a set of two or more inequalities with the same variable and trying to find where they overlap. So we're still going to have our our inequalities in the form of y equals mx plus b, but replacing that equal with a less than, greater than, less than or equal to, or greater than or equal to. We are still looking for the shaded regions where the graph is going to have our answers, and it's going to look a little different now because we will have two inequalities on the graph. So our problems start the same. We want to graph our system so that we can see what our solutions are. So I'm going to start with this first inequality, which is y is greater than 2x plus 5. I'm going to pull out my y-intercept, which is 0, 5, and my slope, which is 2 over 1, meaning up 2, and right 1. So I'm going to graph at 0, 1, 2, 3, 4, and 5. And then I'm going to go up 2 and over 1. And if you want to, you can do it again, up 2 and over 1. When I look at my inequality, it is greater than, so there is no equal to part. So I'm going to put a dashed line on my graph as I graph this particular inequality. And I want to make sure that I get that as straight as possible. Then I need to go through and I need to do a test point for this graph. So once again, I like to pick 0, 0. So I'm going to go 0 is greater than 2 times 0 plus 5. Giving me the statement that 0 is greater than 0 plus 5, or 0 is greater than 5, which is a false statement. So 0, 0 is not included in this graph. So I'm going to go ahead and shade the opposite side then. So everything to the left of this line is going to be part of my solution for the first inequality. So everything over on this side is going to be part of my solution. Then I need to repeat this process with my second inequality. So I'm going to pick out my y-intercept at 0, negative 4, and pick out my slope, which is at negative 3, 2, which is going to be down 3 and right 2. So I'm going to put my y-intercept at 0, 1, 2, 3, negative 4. And then I'm going to go down 1, 2, 3 and right 1, 2. And I can do that again, down 3 and right 2. This time my inequality has the equal sign, so I'm going to put a solid line onto my graph as I graph this problem. And I want to make sure I am going all the way through the entirety of my graph when I place that line. So let me just straighten that out just a tad. And that is our second line. Now, once again, we need to put a test point in. So I'm going to use 0, 0 again. So that's going to be 0 is less than or equal to negative 3 halves times 0 minus 4, giving me that 0 is less than or equal to 0 minus 4, giving me a final statement of 0 is less than or equal to negative 4. That is also a false statement. So once again, 0, 0 is not part of my solution. So I'm going to go ahead and highlight in the other side of my inequality, and that's a little bit hard to see. So I'm going to switch colors quickly, and I'm going to use this purple highlighter instead so that you can see it a little bit better. So I've got this side of my graph. Now, when we are looking for the solution to a system of inequalities, we are looking for the part of the graph that overlaps. So you have two options at this point. Your first option is to take a third color and make it darker where the two overlap. So your first option is to take a third color or take your pencil and make it much darker where these two overlap. So that's our first option. The other option, if you prefer, you can go back and erase the parts where they do not overlap. So you could have erased all of this up here because this only works for the first line. A little bit more difficult for me to erase on the computer because it won't let me get super close, but everything that is on the opposite side of this line should be gone. And then we would also have to erase everything that would be not in the overlap for the other line. So again, you have the two options. You can either color in the area darker, or you could erase to get rid of the pieces that do not overlap. Go ahead and try this one on your own. So the first graph is shown in the light blue here, or the light green. The second graph is shown in the orange. This is an example of what it would look like if you highlighted the overlap. If you preferred to erase and just eliminate those two pieces that do not overlap, it would look like this. Once again, anything in that highlighted area, whether it's shaded darker or whether it's erased, anything in that area is a solution to both problems, which is what we are looking for. So any coordinate pair that lies in this highlighted area is a solution to both problems. Once again, sometimes we have problems that are not in y equals mx plus b format, so we are going to have to fix those. So I'm going to start by fixing the first one. In order to get y by itself, I'm going to add x to both sides. So my new equation becomes y is less than or equal to x plus 3. Going ahead and picking out my y-intercept, I'm at 0, 3. Picking out my slope, which is 1, I'm going to make that 1 over 1 as a fraction, so up 1 and over 1. So I go 0, 1, 2, 3 on my graph, up 1 and over 1, and you can repeat that process, up 1 and over 1 again. I have an equal to sign in my inequality, so that means I am going to use a solid line as I fill this in. And when I graph, I'm going to end up with this line right here. I still need to plug in my test point. Once again, I'm going to pick 0, 0. When I do that, I'm going to plug it back into my original function. So 0 minus 0 is less than or equal to 3, giving me the statement 0 is less than or equal to 3, which is going to be a true statement. So that means 0, 0 is included for this first inequality. So I'm going to highlight to the right of this line, which is going to give me everything over here. Then I once again need to rearrange my equation. So I'm going to go ahead and in this case subtract x from both sides. So my new inequality says y is greater than or equal to negative x plus 1. Picking out my y-intercept, I've got 0, 1. And my slope now is negative 1 or negative 1 over 1, meaning that I'm going to go down 1 and right 1. So I'm going to put my initial y-intercept at up 1, and then I'm going to go down 1 and over 1, and I can repeat the process of down 1 and over 1. Once again, I have an equal sign in my inequality, so that means I am going to use a solid line. And as I do this, when I put my line onto my graph, I'm going to fix that a little bit. I missed my point, so bear with me. I'm going to put my line through my points, and I end up right here. Once again, I need to plug in a test point. Plugging into my original equation, I'm going to have 0 plus 0 is greater than or equal to 1, giving me the statement that 0 is greater than or equal to 1. This is a false statement, so for my second inequality, 0, 0 is not included. So I'm going to go on the opposite side of that line, which is going to be everything on this right side as I am highlighting. So everything over here. Once again, you have the option now to either make the overlap area darker. So I could take my pencil or a third color if you wanted to do this with color, and shade in this area darker so that I know everything in this particular area is going to be a solution to my problem. Or once again, your second option is to go through and erase anything outside of that overlap. So if you preferred to erase, I would erase all of this for my second equation and everything down here for my first equation. So again, you have the option about whether you want to highlight that overlap. Again, a little bit more difficult for me to erase this highlighter on the computer. I don't want to erase my points, but everything over here should be erased if you are going with that eraser method, or you can highlight everything by making it darker. Go ahead and try this one on your own. First one, rearranging by subtracting 2x, picking out your y-intercept and your slope, and then when you plug in 0, 0, it's going to give you a false statement, so we are going to the right of that line since 0, 0 was on the left. The second one, we're going to add x to both sides, giving me y is less than or equal to x plus 3. Plugging in 0, 0, this time we end up with a true statement, so everything that was on the right side of that line is true. Right here, I have it shown where I highlighted that area of overlap to make it darker and left the other pieces. Here is what it would look like if you preferred that eraser method. One last example I want to go through here. In this first one, we are already in y equals mx plus b format, so I can pick out my y-intercept, which is going to be 0, 7, and my slope of 1, 6 tells me to go up 1 and to the right 6. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7 up, and then up 1 and over 1, 2, 3, 4, 5, 6. If I go up and over again, that doesn't fit on my graph, so if you would prefer to add a third point, going opposite, so down 1 and then left 1, 2, 3, 4, 5, 6 would let you complete that. I do not have an equal sign in my inequality, so I am going to put a dashed line onto my graph, and I've got it going through the points. I'm going to have to adjust this because I am on the computer, so I'm going to take this and adjust it down a little bit so I have my line through my 3 points. Once again, then, I need to put in a test point to decide which side to shade. I'm going to plug in 0, 0. So 0 is greater than 1/6 times 0 plus 7, giving me the statement 0 is greater than 0 plus 7, or 0 is greater than 7, which is a false statement. So I do not include 0, 0 in my answer, which means when I highlight, I'm going to go above this line. So I've got everything above this line as part of my solution. For the second equation, I do need to do some rearranging because y is not by itself. My first step then is going to be to add x to both sides, giving me 6y is less than x plus 12. Then I need to divide everything by 6, remembering that there used to be a 1 in front of the x, so I've got y is less than 1/6 x plus 2. As I pull out my y-intercept, I've got 0, 2, and my slope, once again, of 1/6 is going to be up 1 and right 6. So I start at 0, 1, 2 this time, going up 1, 1, 2, 3, 4, 5, 6 to the right, and then I have to go opposite, so down 1 and then left 6 if I wanted to put that second point on there. Once again, no equal sign in that inequality, so I'm going to go once again with a dashed line, and I've got that going through my points. As I adjust, give me a moment to make sure it's all the way through those points. Now I need to use my test point, so once again, I'm going to go 0, 0. So I'm going to put it in for x, and then put it in for y into that original equation, which is going to give me 0 plus 0 is less than 12, or 0 is less than 12, which in this case is a true statement. So 0, 0 is now going to be included as one of my points. So everything in this case is going to go below the line that I have graphed. So all of my solutions for the second inequality are below the line. As you will notice now, there is no overlap between these two shaded areas. So the points that work for the first equation have nothing in common with the points that are shaded for the second equation. Since there are no common points, this would be an example of a no solutions inequality. So there is nothing that works for both of these inequalities. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.